Welcome back, focused learners. Let's get right into it because today's explainer tackles one of the biggest, most expensive headaches in software development right now. How exactly do we take these unpredictable, wildly creative AI models and, force them to do reliable deterministic work? Well, the answer lies in the architecture of something called an agent harness. It's a seriously fascinating concept, and it is completely changing how we build AI applications.
Okay, let's dive into this roadmap. We're going to start with taming the AI black box, then look at what an agent harness actually is, break down the anatomy of a harness, build a basic one together, look at enterprise guardrails, and finally, wrap up with the future of dynamic harnesses.
Part 1. Taming the AI Black Box. Before we even get to the solution, we've got to understand the massive software problem we're actually trying to solve here: reliability and cost. How do we stop non-deterministic AI from lying to us, crashing our systems, and literally bankrupting us? This is the million-dollar question. Because right now, we're building these massive enterprise systems on top of black box compute. You fire off a prompt into the void, and you cross your fingers hoping for a good response. But models are creative, right? They hallucinate, they get confused. If you're trusting that black box to autonomously navigate a web browser or write secure code, you absolutely need a way to stop it from going rogue or getting stuck in an infinite loop that just drains your budget. AI engineer Tejas Kumar put it perfectly in our source material. He said, "Most of us aren't token billionaires." And it's so true, isn't it? We don't own massive server farms. We're essentially paying rent to companies for compute and for tokens. We pay for every single interaction, squeezing them into a limited context window. So because every single mistake costs actual money and every loop drains our budget, we need absolute, unshakable reliability from our agents. Which brings us to section 2. What is an agent harness? Now, what's really interesting about this slide is how the definition of a harness completely shifts depending on who you're talking to. If you go up to a traditional machine learning engineer, they probably tell you a harness is just a glorified test runner, a way to feed a model inputs and check the outputs. But in the modern AI engineering world, where we're building autonomous agents, an agent harness is something entirely different. It represents everything around the model that grounds it in reality. It's the safety net. Let's make this highly technical concept super concrete with a couple of physical analogies. Think about mountain climbers. They use a physical harness to anchor themselves to a stable rock face, right? So they literally can't fall off the mountain. Or think about taking your dog for a walk. You use a leash, which is a type of harness, so your dog doesn't suddenly dart into traffic or chase a squirrel 3 miles down the road. An agent harness does the exact same thing, but for a language model. It ties an unpredictable, highly creative intelligence to a rigid, deterministic environment, so it simply can't drift off into hallucination land.
All right, section 3, anatomy of a harness. So let's take those physical concepts like the dog leash and map them into actual software architecture. Here are the moving parts of a typical harness. First up, you have a tool registry. This is what gives the model access to the real world, like the ability to read a file or execute bash commands. Then, of course, you have the black box model itself. Next is context management. This is super important for compressing memories so you don't run out of tokens. Then you have crucial guardrails, like setting a strict limit on how many steps the agent can even take. After that, the agent loop itself. And finally, a verify step to double-check the agent's work. The really big takeaway here is that the harness isn't the loop itself. It's all this architectural scaffolding built around the loop that keeps it grounded.
Before we build our own, let's look at what an unharnessed, totally naked agent loop looks like. It's actually incredibly basic. Step 1, prompt the model. Step 2, check if the model says it's done. Step 3, add whatever it just did to a trace history. Step 4, repeat while true. Now, as you can probably guess, just repeating this indefinitely with a creative black box model is pretty much a recipe for an expensive disaster if that model gets confused. Section 4, building a basic harness. Okay, we are going to watch a poor man's harness get built from scratch, and I want you to think of this almost like an iterative detective story. Here's our demo objective, the Hacker News mission. The goal is simple. Instruct an AI agent to open a browser, navigate to Hacker News, and click the upvote button on the top post. But here's the twist. We are intentionally using a cheap, kind of outdated model from 2023, GPT 3.5 Turbo. Why? Because we want to prove that great architecture matters way more than just paying for the smartest, most expensive model. So we run our unharnessed loop with this instruction. What happens? Well, the agent successfully opens the browser, it sees the upvote button, and it clicks it. Great! But then it hits a wall.
Hacker News requires you to be logged in to vote, so the agent hits a login redirect screen. It has no idea what to do, so it panics, crashes, and then confidently reports back to us, "Success! I upvoted the post." It literally just straight up lies to us. Now, the amateur move here would be to go back and tweak the prompt, but we're not going to touch the prompt. We are going to build a harness. The very first fix is adding some default guardrails, basically putting a short leash on our dog. We implement a hard rule. If the agent takes more than 6 steps, kill the run. Absolutely no infinite loops allowed. Second, if the context window gets too full, we trigger a naive context compressor that aggressively deletes the middle of the conversation, leaving only the original system prompt and the 2 most recent messages. Our source playfully calls this a pregnant harness. It's not fully mature yet, but we're starting to enforce strict boundaries on what the model can do. Next up, we have to stop the agent from lying to us. So we build out our verify step. Because our harness has been keeping a trace history of every actual browser click the agent made, we can use completely deterministic code, just regular non-AI programming, to look at that history. If the agent says, "Hey, I succeeded," but our trace history clearly shows it was redirected to a login page, the harness pulls on that leash. It acts as a lie detector and forces an early failure return. The agent is literally forced to admit it failed. And hey, step 1 of solving a problem is admitting you have one, right? Now, for the really brilliant part, the login handler. We definitely do not want to give an unpredictable AI our secret passwords. So instead, our harness runs a check during every single loop. Is the browser currently on a login page? If the answer is yes, the harness steps in and hits pause on the AI. The harness itself, using secure traditional code, grabs our hidden credentials from an environment variable, types them in, clicks submit, and then hands control right back to the AI agent, basically saying, "Hey, I handled the login, you're good to proceed." This is just flawless secret management. So the crucial point is what happens when we run it again. The agent clicks upvote, hits that login screen, the harness detects it, injects the secret securely, logs in, and hands it back. The agent then clicks upvote again, and this time it actually succeeds. We achieved total success using a cheap, outdated model, and we never once altered the original text prompt. We solved a complex AI problem purely through robust software architecture. Section 5. Guardrails in the enterprise. All right, it's fun to script a Hacker News bot, but let's broaden the scope to high-stakes enterprise applications. Take a look at this comparison. If you deploy a naked, unharnessed agent in a massive Fortune 500 company, you are forced to pay for the most expensive frontier models just to get baseline reliability. Plus, it's vulnerable to prompt leaks, and it will almost certainly hallucinate when asked about internal company data. But an enterprise harnessed agent, like IBM's Open RAG project mentioned in the source, totally different ballgame. The harness handles secret injections securely. It performs deterministic retrieval augmented generation, meaning it specifically queries siloed private PDFs and Teams calls before ever letting the model speak. It makes the entire system highly secure and completely grounded. And this connects right back to your company's wallet. The ultimate promise of the agent harness is doing more with less. If your architecture is rock solid, your guardrails, your verification steps, your tool registry, you don't need to rent the absolute most expensive models on the market. You can actually use cheap, open-source models that run locally and still achieve highly reliable, secure, professional results. The magic is in the harness, not just the model. Section 6. The future. Dynamic harnesses. Let's shift our focus to the future of AI engineering and what comes next in this incredible evolutionary arc. And this brilliantly illustrates our trajectory right here. We look at 2025 as the year autonomous agents really broke into the mainstream. But as companies quickly realize that agents are inherently chaotic, 2026 becomes the year of harnesses. Everyone is going to be focused on building these deterministic safety nets. But what about 2027? The prediction is that we'll enter the era of dynamic harnesses. So what exactly is a dynamic harness? Imagine a system where you give an agent a really complex task, like buy me a flight to Tokyo. But before it even tries to open a web browser, the agent analyzes the task, anticipates exactly where it might hallucinate or get stuck, and programmatically writes and deploys its own custom software harness. It builds its own safety net on the fly. It is like a self-aware plan mode on steroids, ensuring it has the exact right context, limits, and verification steps needed for that specific job before it executes a single step. Which leaves us with this pretty provocative thought to end on. Are dynamic, self-generating agent harnesses the next logical step toward true artificial general intelligence? I mean, perhaps the secret to AGI isn't just throwing billions and billions of dollars at training ever larger black box models. Perhaps the true path forward lies in AI engineering, in teaching models how to build smarter safety nets, manage their own context, and dynamically ground themselves in reality. It's a massive paradigm shift, and one you're now fully equipped to understand. Thanks for learning with us today, and we'll catch you on the next explainer.